In this video, we derive the last two kinematics equations that can be used only in the case of constant acceleration. So to derive equation 3, and there it is, so this should be our final answer, we're going to break this trapezoid into two parts, a rectangle and a triangle. I'm going to go ahead and do that right there. You can see I've got a triangle on top, and then I got a kind of a skinny rectangle here on the bottom. Use the graph to write the expression for the rectangle's area. Include a designation for the proper physical quantity on the equation's left side. We've said that the area under a velocity time curve is displacement. So the displacement for the rectangle, put a little r there, is, well, that's going to be the area. So what's that? How about t is the width there, and then this little height is v naught. So far, so good. Letter G. Use the graph to now write an expression for the triangle's area. Again, designate an appropriate quantity on the equation's left side. So the displacement bit for the triangle is going to be what? Well, what's a triangle's area? 1/2 times the base times the height. Okay, what's the height of this? Well, it's not VF, but it's VF minus V naught. So the height is VF minus V naught, and the width is time. Use equation 1 now, which we went through in an earlier video. Use equation 1, and there it is, to modify part G so as to get rid of the parentheses. All right, if we want to get rid of the parentheses, let's see here. I think we can say that the VF minus V naught is equal to A times T. Isn't that correct? From this equation here, if you subtract V naught from both sides, don't you get that? Well, VF minus V naught is right there. So I think we can say that that portion right there is going to be 1/2 times A times T, which is A T squared. All right. Combine parts F and H to derive equation 3. Well, the total displacement then is going to be the sum of these, which is V naught times T plus 1/2 A T squared. There you go. And that is equation 3. Lastly, we derive equation 4. We're going to begin by solving equation 1, and there it is again for T. Can we do that? We're going to subtract V naught from both sides and then divide by A. Now we're going to substitute that into equation 2. There's equation 2. I've recopied it there for you. And let's not simplify it quite yet. So let's go delta x is equal to 1/2 VF plus V naught, and then multiplied by time. But up at the top of the screen, time is that. So, and it says don't simplify, so let's leave it like that for a minute. And now, letter L, now we want to simplify this. So when we simplify this, VF plus V naught and VF minus V naught, let me rewrite my delta x, and we've got a 2 in the denominator, I got an A in the denominator, so let me put those there. And then VF plus V naught times VF minus V naught, hopefully you learned in your math class that that can be simplified to VF squared minus V naught squared. And can we rearrange this? What does equation 4 need to look like? You could look back at what we did a couple videos ago, but usually equation 4 is solved for VF squared. What would that look like? The 2A would be multiplied by the delta x, and then we'd add V naught squared. I think it would look. So we're never going to derive those 4 kinematics equations again, but they can be derived, and we've just done it here. And remember, they can only be used in cases of constant acceleration.